We're given a point that lies on a circle with center 0, 0, and we're asked to find the equations. So let's just sketch out a general circle centered at the origin. Okay, you either know the equation or you don't, probably at this point, but I'm gonna kind of derive it. So if I pick up a general point, x, y, then I can draw a line going to it, and that line is the radius. But how many have I gone along? I can then create a little triangle. How many have I gone along? I've gone along x, and I've gone up y. I've got a right angle triangle. I can write down that x squared plus y squared equals r squared, and that is the general formula for a circle centered at the origin. If I moved my x, y to somewhere else, it would be the same thing. I'd just get a different value of x, a different value of y, but the r would still be constant. So the question is, I suppose, what's r? Because all the rest is sorted. I've got x squared plus y squared. I just need to write down what r squared is. All right. Well, then let me replace xy by minus 5, 2, although actually it should be over here. So I'll do it over here. Minus 5, 2. And that means I've actually got a triangle that has a base of 5. I know it's in the negative direction, but I'm just considering the triangle by itself now, and a height of 2. I'll draw it over here. And then I've still got r as that hypotenuse. So r squared is equal to 2 squared plus 5 squared, which is 4 plus 25, which is 29. And that's what I need. So x squared plus y squared equals 29. Work out the gradient of the tangent to the circle at this point. Okay, let's give that a go. I'm going to draw it out again. And it doesn't have to be perfectly to scale. You know, that'll do there. Okay, I am going to write in minus 5 this time because I'm going to use my gradient triangle in a slightly different way. Because basically, right, what am I trying to find? The gradient of the tangent. That is going to be this thing here. That's the tangent. I don't want the equation of the tangent. That's a different question. I just want the gradient of the tangent. Now, what I need to know is the fact that the radius at the point is actually perpendicular to the tangent. So first of all, find the gradient of the radius line. It's actually called the normal, but I'm going to call it the gradient of the radius in this case. Okay, and this is why I need to have my minus 5 in there, because actually it's rise over run. So it's going to be 2 over minus 5. You can see I've got a negative gradient. And that means the gradient of the tangent, right, just need to remember this little fact. If you have two lines that are perpendicular, and when you multiply the gradients, you get minus 1. So if I have a line with gradient 2, the perpendicular line has gradient minus a half. If I have a line with gradient a third, it would be minus 3. I take the negative reciprocal. So in this case, I take the negative reciprocal, and it's going to be 5 over 2. Because then I can see that 2 over minus 5, which is the same as minus 2/5. If I times that by 5 over 2, then these will cancel and these will cancel, and I'll be left with minus 1. They cancel, but they leave me a 1. So I'm not showing all my working there. Maybe I just write negative reciprocal above it. It's only 2 marks. That'll be enough working.